Okay, let's do another backtracking. Since it's backtracking, I always gotta pull up the whiteboard. So let's do this. So matchsticks to square. You're given an integer array, matchsticks, where matchsticks of y is the length of ith stick. You want to use all the matches to make one square. You should not break any stick, but you can link them up, and each matchstick should be used exactly one time. Return true if you can make this square, and false otherwise. So we have length of 1, 1, 1, and we can say this true because we can basically make everybody, you know, a 2. So that's good. Here we take the max, try to make everyone else a 4. You can find a way to make the square with. We cannot find a way. Okay, makes sense. I mean, if this was a 3, this would be yes. Actually, no. Right? You have to use all the matchsticks, right? So first off, I can't rule it out yet. Okay, so I have another idea. So then we'll do this. We have 3. So I guess the backtracking is like this, right? So we have all the values 1, 1, 2, 2, 2, right? These will be made up of 4 values. We need 4 total values. Where to make a square, we're all of the same length, right? So I think we can do like a backtracking scenario. So we take 1. We can take 1, right? As a starting point, we'll take the first value as the starting point. And our goal is to, I guess we just take the maximum, right? The max goal is to make, I guess, 2, right? I guess the goal length is 2. So have we reached our goal length? Okay. Yeah. Have we reached our goal length? No. So we recurse down. I guess the base case is basically if you're equal to goal length. So we can return early out. If you're not, then we're going to recurse more. So we'll go explore all these values, right? So yeah, now we pick another value. Yeah, we'll take 1, I guess. So we'll try to take 1. So we add it up, 1 plus 1. So that's going to be 2. And when we try to recurse down again, we're going to bubble up and add it to the list because we've reached our goal. And then we pop all these back, and then we'll choose another one. Starting from this guy. And then we go down, and we'll probably bubble out here because we exceed it. So we skip this guy. Now we go to here, bubble out, add this guy. Go to this guy, exceed out. Right, it perfectly matches. So we add that, and then we again add that, and then boom. And then check if the length equals 4. Perfect, yeah. I think that should work, kind of. Let's try this. So we have a res here. Return if length of res equals 4, and then backtrack. Def backtrack. I don't know, something else. Probably pass resin, I guess. Backtrack res. Let's do this lengths. So base case is if lengths, I guess, so if lengths, not okay. I shouldn't pass. I shouldn't pass lengths. I should pass. Yeah, I shouldn't pass this. I should pass the index, I guess. No, not even the index. I should do the current value. The current sum. I guess is 0 for now, and then if cur sum equals the max, so I guess goal length. I'll pass in that goal length. Goal length equals, I guess, the max of match sticks, right? So our goal is to make everybody look like 2 and have a total of 4 values. So if we have our current sum equal to goal length, then res.append cur sum and return out. If at any point we exceed it, so if cur sum exceeds it, return out. No point of exploring that case any further. Then we just do for every match stick in match sticks, right? For every match stick in match sticks, we'll cur sum match stick, backtrack cur sum, the goal length, and cur sum. We'll obviously want to explore further, so that's that. Okay, yeah, that kind of makes sense. Hold on, let me break this down though. This probably is not going to look good. Okay, so we have here a goal. So we're going to start at, shit, hold on. I made a mistake already. I don't want to repeat values. This makes no sense. I need a matchsticks. I'll pass in a sliced version of it. So we'll do match ms, I guess. We'll pass in match sticks. Yep, match sticks. Okay, so we'll pass that in. And I'm going to rework this really quick. So hold on. We'll do enumerate. All right, can we just learn how to type? Oh, so we'll do that here, and then we'll do I like this, and then we'll pass in a sliced version of it, starting from ms of I. Okay, I made a mistake. We should call this ms. Yeah. Okay, so does that make sense? No. Not starting from I and beyond. So starting from I. So we start from zero all the time? No, that doesn't make zero fucking sense. No. I should not go backwards. Hold on, I messed this up again. Oh, no. Since I'm slicing it, the next iteration, right? 0, right? It's going to start at 1. Or like the sliced version of it. Like, okay, I pass in a full list, right? And then there's going to include the very first value. Then I'm going to start 0, and I'm gonna start again at the fucking thing. No, I should start at 1. Yep. So I'll start at 1. So yeah, it's from 0 to, yeah, it starts at 0, and it'll yeah, well, it'll start at 1 actually, since we're starting at 0 essentially. So we take the first value. Oh no, it's gonna ruin our thing. Okay, let me screw this for every, I'm gonna pass in the index to start at. Yeah, we'll do start, which was obviously at 0. Okay, so for every I in range from start to length of matchsticks, we'll do +1. Well, I don't know if that's bad actually. Okay, anyways. Okay, so we'll do matchsticks of I, cur sum, increment that. Then we call backtrack, and we'll basically start from I plus 1. Yeah, with the current sum, and what is this? The goal length. I don't even think this is necessary. I just get rid of that. Just call it globally. Yeah, goal length. Okay, so yeah, we backtrack and we start basically like that, and then cur sum like that. And then before I even just do anything, print res. Let me just see something. Yeah, we don't need this. So we got no lists. Yeah, that's exactly what we didn't need. This is bad. Okay, this is bad. Okay, hold on. Let me think again. Let me see why this is happening. All right, so we have here. Oh my god, no. We need to do this. I messed this up. Yep. Okay, let me try that again. Oh, we got a total of 4, which is actually what we want, though. Oh, no, not that. Total of... Oh, there it is. Yeah, that's exactly what I wanted. Okay, perfect. Yeah, that's kind of what I wanted, actually. Okay, so length of res equals 4. Yeah, will this work? I doubt it. Yeah, got a wrong answer this time. Okay, so why is this wrong? Let me see. We got a false, but we expected true. Our goal was to make everybody look like 10. So yeah. Maybe I should sort it. Does that make a difference? Matchsticks dot sort. No, it doesn't make a difference. My idea is probably that it's like we're picking the biggest one, and then, well, yeah, that should add it. Yeah, our goal is that, so we add a 10. Let me see what this looks like actually. Print this. Yeah, so we should have a 10. Oh my god, that is fucking wrong. Okay, so first off, we start at 0, right? We add the 10. 10 is equal to our goal length, right, which is 10. So we actually append the 10, right? Oh my god, actually, never mind. Ah, yeah, I got this whole thing wrong. You can make a bigger value. That's so much harder, actually. I think my side picking is wrong. Let's actually, maybe we just do the perimeter, which is like the sum of the matchsticks divided by 4. That would be a possible one, because I think me picking 10 is not realistic. Like, I can exceed 10 and somehow make it up to be it, you know? Okay, let me see if that looks reasonable, though. Okay, everybody is 12 this time. Well, actually, yeah, that's fine. Okay, yeah, hold on. Okay, I think I have the idea wrong here. So I should probably, well, I think I have the goal idea right. So it's also should be, I also should make sure if the sum of matchsticks, mod 2 or mod 4 does not equal 0, then return false. I think it makes your lives a little easier when we do that. Okay, that's not gonna fix anything, but there's still more issues here. I'm not really counting. I'm like counting like all the possible subsets and stuff. So I should probably make a scratch this backtracking solution. This is not. I'm like doing all the possible combination subsets. I need to do like other ways to optimize it. So def backtrack. All right, we'll call backtrack. Right. We'll do sides, and we'll pass in the index as well, so we can go through all the matchsticks. And then we need to build the sides here. Like put a 0 for in range of k, or k being 4. So first, so let's just make like basically a bunch of zeros. Well, why do I even try doing that? Let's just write it out. Right. For every single side, we'll have a starting point, and then we just need to make the goal length, which is this. So we'll do this. And then, yeah, that's fine. Yeah. And then the index will do return backtrack of 0 to sides. And the backtrack will return me a boolean. So the base case is if index equals length of matchsticks, sticks, then we've used all the values we could. Now just return me like if the sides are all equal. Sides of 0, sides of 1, sides of 2, sides of 3. They're all equal to the goal length. Or let's call it goal side. Yeah, let's do that instead. Makes more sense. If that's true, then that's good. And then we'll do for every in range from, or I think for every I in a range of 4, for all the sides essentially. I'm writing the value so it's more explicit. So side 0, side 1, side 2. We're going to sides of I. We're going to add the index version of it. So like this. Of the matchstick. So if so, okay, there's got to be another case here. So if matchstick, so we'll do sides No, I don't want to add this yet. Let me do this. If, right, if it's less than or equal to our goal side, right, then that's still potentially something, right? Then let's do, we'll actually add it to the thing, right? Sides of I plus equals the matchstick of index, right? At the value. Now try if backtrack of I plus 1, like the next value, right? Like we used up this guy. Now let's use up this guy. Right, we're gonna basically try the, like, starting here. And if we return true, meaning like eventually we're gonna keep recursing and use all the values up. And if it happens to be the case here, then we can return true. Of course, we passing this here. We can return true. And then since that was one possible, if it's false, then we probably want to undo that. Sticks of I index. Yep. And then return false here, because eventually I'm going to have to return true. Meaning like someone's gonna hit this, but if we never hit that, then that was not a good one. It's not possible. So I think this should maybe work. Closer. Hold on. So this is false when expected true, because I'm close somewhere. Hold on, let me think about this. Sides of that. Yep. Index. Yep. Goal side. Yeah, that's fine. I also should get rid of the largest one right here. So like, okay, so matchstick, matchsticks dot sort. I not get rid of. I wanna start like ascending, because like when I pick a big value, that's just gonna like ruin the math. I feel like ascending is better. Should be a little bit better, but I don't know. Okay, do we get an infinite while loop? GG's, boys. No, timer exceeded. That's annoying, bro. Come on. Yeah, because I want to pick a value from that and beyond, you know? Wait, what am I missing here? 0, 1, 2, 3. 0, 1, 2, 3. Yep. Okay. Maybe, okay, hold on. I actually should not. I want to use the global slides. I don't want it to like alter it like. Yeah, I don't want it to alter it like as we're going. Yeah, my bad. No? Okay. What am I missing? Why am I chilling, bro? Hold on, maybe if the sides of I equals 0, if there was no change, then just break out. No. I don't know why this is broken. Should it just only be the the first three and then the last one should like fix itself, I think. I don't know. I don't know why it's tealing, to be honest. Why is it tealing, bro? I don't know. Oh my god, no, not this one. Okay, it's this index as in like the global index to to access to array. Yeah. Right? Okay, fix that, but do I still get a Tilly somewhere? Oh my god. How is this worse actually? So I should sort it from that. Wait, let me. Why did I remove this actually? Sides of 3. Yeah. I should try all the sides, right? Wait, I got a Tilly. That doesn't make matter. Maybe I should do the bigger values first. Reverse equals true. And then we will ignore. No, that's fine. Right? So like we try bigger values first. Okay, that works. All right, see you guys tomorrow.